Hello everyone, welcome to Mifratech. Today in this section we will learn about smart irrigation system project. So the following concept will be covered in this video. First we will see the introduction about the project and a proposed block diagram and the components required in order to develop this project, and a detailed circuit diagram in order to see, in order to connect each individual sensors and controller required for this project. And finally we will see how this project is going to work and where you can use this project. So this smart irrigation project will be used in agriculture and in irrigation field in order to provide efficient only required amount of water to the plants. So mainly in this our proposed system we are going to use Arduino Nano microcontroller and a relay module, water pump and a water level sensor in order to know whether water level is high or no. So depending on those water level values, we are going to, whenever the water level is low, we can automatically turn on the pump to provide water supply, and when water level is high we can automatically turn off the water pump. And we can also measure temperature and humidity using DHT11 temperature sensor, and soil moisture sensor will be used in order to know whether the moisture level of the soil is high or low. So all those things will be displayed in the serial monitor, and we can see all the required parameters for this irrigation system. So this is our proposed block diagram. So mainly we are using Arduino Nano microcontroller and a power supply. In order to provide power supply for the controller and the various sensor, we are using 5 volts DC adapter, and in order to check the water level we are using water level sensor, and in order to measure the moisture level of the soil we are using soil moisture sensor, and a temperature and humidity we are using DHT11 sensor, and in order to automatically turn on and turn off the water pump we are using relay module, and in order to pump the water we are using water pump. So this is our proposed block diagram for this smart irrigation project. So the hardware components required for this project are Arduino Nano microcontroller, a soil moisture sensor, temperature and humidity sensor, that is DHT11, and water level sensor, and a water pump. A one channel relay module will be used, and a jumper wise in order to connect various components, and a 9 volts additional battery will be connected for the water pump, so because it requires more power. So and in order to provide power supply for the whole system you are using 5 volts DC adapter. So these are the hardware components required for this project. So the software components required will be we are using embedded C programming language, and we are going to write it in the Arduino IDE. So this is the detailed circuit diagram for this smart irrigation project. So mainly the components will be Arduino Nano microcontroller, a DHT11 temperature sensor, and a one channel relay module, water pump, a 9 volts battery, soil moisture sensor, water level sensor, and a 5 volts DC adapter, and there will be a power junction. So here this power junction, why we are using this, in order to provide normal power supply and ground to all the components we are making use of this power junction. So for the first connection will be 5 volts DC adapter we are going to plug in, and it provide 5 volts DC supply. So here positive pin of this positive wire of this 5 volts DC adapter will be connected to 5 volts of this power junction, and the ground will be negative will be connected to ground of this power junction. From this 5 volts and ground only we are going to provide common power supply and ground to all the components and the controller. Next, this Arduino Nano microcontroller both has analog and digital pins, so we are making use of both in this project. So next we will see how to connect this DHT11 temperature and humidity sensor to this Arduino Nano microcontroller. So this DHT11 sensor mainly has 3 pins. A positive pin in order to provide a power supply to the sensor, so that I have connected to 5 volts from this power junction. Next we have negative pin, that is ground, that has to be grounded, so I have connected to ground of the power junction. Next we have output pin, so this is a digital output pin, so that so only I am connected to digital D4 of Arduino Nano microcontroller. This is the required connection to interface this DHT11 temperature sensor to Arduino Nano microcontroller. So next we will see how to interface water level sensor to Arduino Nano. So water level sensor has mainly 3 pins. A negative pin has to be connected to ground of the power junction, and next we have plus pin, that is positive, that I have connected to 5 volts from the power junction in order to provide power supply for the water level sensor. Next we have SR signal as the output pin, so that I have connected to analog pin, so only water level sensor will give analog value, so only I have to connect analog pin of the nano microcontroller. So I connected to A1 of Arduino Nano microcontroller. This is in order to interface this water level sensor. Next we will see how to interface a soil moisture sensor. So this soil moisture sensor has 2 components mainly, that will be a controller board and a probe. So probe doesn't have any polarity, so we'll connect probe directly to this controller board. So this soil moisture sensor control board mainly has 4 pins, a VCC, the digital output, analog output and a ground. So VCC in order to provide power supply for the soil moisture sensor, so that I have connected 5 volts from the power junction, and ground pin I have connected to ground of the power junction. Next, in this example we are connecting this soil moisture sensor to only the analog output. So A0 I have connected to A0 of the Arduino Nano microcontroller. This is in order to interface this soil moisture sensor. So next we will see how to interface a one channel relay module to nano microcontroller. So this one channel relay module has 3 pins here, VCC, ground and input 1. So VCC in order to provide power supply for this relay module, so that I have connected to 5 volts from the power junction. Next we have ground, so ground I have connected to ground from the power junction. Next input 1 in order to control this water pump, so that I have connected to D3 digital pin of Arduino Nano microcontroller. So this is the connection in order to interface this one channel relay module to Arduino Nano microcontroller. So next we will see how to connect this water pump to relay module. So this water pump has 2 pins, mainly positive and negative. So positive pin I have connected to NO of one channel relay module. So so this water pump requires additional power supply, so only I am using a 9 volts battery here. So this 9 volts battery has 2 pins, like 2 wires, positive and negative. So the positive I have connected to C of this one channel relay module in order to provide power supply for this water pump, and negative pin I have connected to negative pin of water pump. So this is the required connection in order to connect this water pump to relay module. So these are the required connection for this smart irrigation project. So like how we connected each individual component to specific pin of Arduino Nano microcontroller, the same way we have to program it in the Arduino IDE, and we have to dump the code to this Arduino Nano microcontroller. After dumping it, this project will work like how I told. So mainly that AST11 temperature sensor going to give temperature and humidity values of the surrounding that can be seen in the serial monitor. Next, water level sensor will measure the water level, and it is going to give water level is high or low. So that can be seen in serial monitor. Whenever the water level is low, so the Arduino Nano microcontroller automatically turn on the water pump through one channel relay module. Whenever the water level is high, it is going to turn on this water pump using relay module. Next, soil moisture sensor will give the moisture values either high or low, and that values can be seen in the serial monitor itself. So in this way we can this smart irrigation system will work. So you can make use of this smart irrigation system in order to efficiently provide water supply to the crops, and in order to see the different parameters of the surroundings like temperature, soil moisture and humidity, etc. So thank you for watching the video. Thank you.